Alkane, alkene. In a crude oil deposit, there is a mixture of long chain and short chain and with many branch or aromatic. Market demand for short chain of hydrocarbon, which is used for car petrol. But for the long chain hydrocarbon, we need a lot less. So what we end up in a tub of crude oil, there is a lot of excess of long hydrocarbon chain. And what we're going to do with it? Are we going to simply throw it away? And that's what we're going to deal with on this topic. Cracking. Cracking is to convert this long hydrocarbon from a high molecular mass to lower molecular mass. What is high molecular mass? This is high molecular mass, those long chain, and lower molecular mass, the shorter chain. Cracking is to cut it into the shorter pieces so that you can use it for petrol. And now we talk the method. An old method called thermal cracking. When you heat this crude oil to 1000 degrees at that high temperature and without air, this crude oil, this hydrocarbon chain will start to break up into short pieces. But this is very expensive to run and difficult to control the end product. Why? Student, think about what is meant by 1000 degrees. 1000 degrees is a very high temperature. Copper melting point is around 800. Iron melting point is about 1200. So 1000 degrees and you're heating on crude oil. Crude oil is very flammable. So this process have a lot of danger in it. The second method, catalytic cracking. This time they're using a catalyst called cellulite. By using catalyst, heating at much lower temperature without air, it requires about half the temperature, 500 degrees, and this is what we use in our petrol refining. Now let's look onto the graph. And on the graph it shows without catalyst, you require much higher temperature. You need to have a higher temperature for called the activation energy. But with catalyst, you can lower the temperature by 500 degrees. So catalyst help to lower the activation energy. And it also increase the rate of reaction. Student, please remember, catalyst function is to lower the activation energy and increase the rate of reaction. And by lower the activation energy, very often you see it requires much lower temperature for the reaction can carry out. The last one we're going to talk, steam cracking. Steam cracking is to convert ethane into ethene. That's on the natural gas deposit. Now let's go more detail about the catalytic cracking and steam cracking. Catalytic cracking. The main catalyst they use is called cellulite. What is cellulite? Cellulite, when you're under the microscope, they are a network structure. Of this network, it contains many tiny little holes, which this look like a honeycomb under the molecular structure. And when you have a long hydrocarbon chain, this long hydrocarbon chain can absorb into this tiny hole and start to break up. And here I show example. Here, when you see this long hydrocarbon chain, this long hydrocarbon chain will fit into the size of this pore and be reacted, and it start to cracking into short pieces. And that's how it's cracking up mean. And now let's focus on to the molecular formula. For example, cracking of a decane to produce octane and ethene. Look at the formula: C10H22, octane CH-H18, ethene C2H4. What does that mean? Now, student, I hope this may remind you. Decane, it is a single bond. As you can see, decane and octane is a single bond. So the formula, this is the formula. And ethene, ENE, is a double bond. And the formula, and this is the formula. So you start to require to understand the formula to draw the structure. Now let's continue. What will be the structure, the molecular structure look? As this is a single bond, decane ANE, octane ANE is a single bond, so this is going to the structure of a single bond. And what will it produce? And when it cracking, it will crack and cut it shorter. And now it become two pieces. One piece is C8, another is a C2. And now let's focus on to the short chain C2. This C2 is a double bond ethene. Is a double bond ethene, ENE. As you see on the top, this is a ethene and this is a structure. And what happened to the remaining? The remaining is as a single bond, C8H18. The rule of this cracking is restricted by the size of this pore of the cellulite. And on each cracking, it always will crack into the ethene double bond and the remaining single bond product. Repeat, of each cracking, it always cracks into a double bond 2C ethene and the remaining product. Now let's talk steam cracking. This is from the natural gas deposit of all the ethene 2C, propane 2C, 3C. Of the formula, those C2H6, they also convert into C2. Why? Look onto the difference. Of this ethane, they crack it into ethene, which is a double bond ethene and hydrogen gas. So you can see on both types of cracking, Both types of cracking, the end product is ethene. And this ethene is going to be our major topic that will be continued on and on for many lessons. Ethane, ethene. And what is the difference? Alkane is unreactive. They mainly used for fuel. Alkene are reactive because of the double bond. Now let's look more detail. Alkane is unreactive, and this is a single bond, so they mainly use it only as a fuel for burning. Alkenes are reactive because of the double bond, so they can use it as a start material for many synthesis reactions as follows. Here is a picture to demonstrate, and you can see what's in the center. Ethene. Ethene are most versatile, and they widely used as a raw material to produce plastic, solvent, pharmaceutical, or insecticide, etc., etc. They have many uses. Now let's talk about how's the reaction of ethene. This is called addition reaction. All this addition reaction is due to ethene double bond. And when this double bond have a X and a Y, they will combine the X and a Y into a new product. Now let's show. In ethene, you have a double bond. And these double bonds are reactive, and they can open up and break. And then it can form with the product as follows. And now they become a new product. Now let's look on to more examples. Ethene by adding hydrogen. This ethene can convert it back into ethane. This is called hydrogenation. Hydrogenation. Student, please pay attention to the structure change. Ethene also can by adding water, H2O. This is called hydration. Hydration. And by adding H2O, now you can see this H as this H and this OH as this OH. And now they form into a new product, ethanol. Ethanol. This to demonstrate this ethene double bond can react by addition reaction. Now let's look more example. What is unsaturated hydrocarbon? Unsaturated hydrocarbon means any hydrocarbon with double bond, triple bond. As follows. Butene, double bond. So this is a unsaturated hydrocarbon. The bottom one, butane, single bond. So this is a saturated hydrocarbon. We can separate and distinguish this saturated and unsaturated hydrocarbon. The test we call bromide test. bromide is a dark brown color solution, and this dark brown color solution especially can react with all the double bond ethene. So here is the example. Now let's look on to the top one. If you put this dark brown color solution onto the clear ethene solution, if you mix it together, they will simply turn it into a lighter color. As you put some dark color Ribena onto a water, you become lighter color. So there's no chemical reaction you can see. This happens to all the saturated hydrocarbon single bond. And now let's look onto the bottom one. If this is a double bond alkene, ENE, unsaturated, this double bond will react. So this bromide water, they will break open and form into this new product. And this new product will be colorless. So when you put this dark brown color into this double bond solution, you shake it a few shakes, the color will all gone and disappear. And this is look very much like playing magic. With a dark brown color solution, after a few shakes, the color all gone become clear. So the conclusion: bromide tests can distinguish saturated single bond hydrocarbon from unsaturated double bond hydrocarbon. If it is a saturated single bond hydrocarbon, no reaction, it simply gets lighter. But if it is a double bond unsaturated hydrocarbon, they will lose the color, become clear, because of the reaction of the double bond break open and react.